Welcome back, Algebra 2. We got some stuff to take care of. What we're going to be taking care of today is what we're calling QUAD7. I mean, it's just about graphing quadratic functions, but we're going to go ahead and call it QUAD7, just so you got something to all relate to here. Basically what we're doing, we've done some similar stuff already to this. We've had these discussions already. Up to this point, we've done a lot of solving, right? We solved by taking square roots. We solved by factoring. We solved by completing the square. We solved by, this is quadratics, we solved by taking the quadratic formula. We did some circle work where we applied those things, and now we're going to kind of take that plus what we did at the beginning of the year, that whole domain range end behavior, how do functions actually work. And so we're gonna take that and kind of go to the next step with that for quadratic functions. So what we start with here is quadratic functions are the functions where your input or your independent variable, which is generally what we call x, it doesn't have to be x, but we generally call it x, is raised to the power 2. So it's something that's squared, okay? It's different than a linear function. We end up with kind of like a U-shaped thing most of the time. In this case, we do. We say that shape is called a parabola. A parabola. Parabola. Now, at the beginning of the year, when we did some things with quadratic, with all kinds of functions, we talked about how to transform functions. Remember that one? We did a little bit of that one. So this is kind of something similar, but a little bit different. We're going to be more specific to quadratics. Let's say we've got 3 different versions of how a quadratic could look. What's interesting is you could make these look the same, right? It's kind of funny. All 3 of these things are all quadratic functions, but they just look a little bit different in terms of their style. The first one, this ax squared plus bx plus c, that should be a little bit, I don't know, I want to say too familiar, but something we've seen several times coming up. We call this standard form. So that's one way we're going to take a look at it. This is the one we started with at the beginning of the year, the translations and transformations, right? A times x minus 8 squared plus k. We called this one, and I like this one, vertex form, because we're going to get that vertex directly. We'll see that here shortly. And the last way that we do this is what we call intercept form, because we have a couple x-intercepts. So intercept form. So basically what we're trying to get across in these 3 forms, and this one target, these 3 forms, is how do we sketch the graphs and what are some important parts of this graph or these graphs? Vertex is going to be important. We're going to talk about an axis of symmetry. We're talking about y-intercepts. We know what that means. We'll take a look at those. And then just the general sketching of the graphs. So let's go ahead, kind of do some general stuff, right? We've all got, notice all 3 forms have an A multiplier somewhere. This A is what determines if the graph opens up or down, right? Maybe it's a reflection over the x-axis. Remember that one? That should come back to you. If A is positive, we don't change. We don't have a reflection. We just say that opens up. If it opens up, that vertex point is a minimum. If A is negative, our parabola opens down and we have a maximum for a vertex. All right. Again, vertex, all quadratic equations have this vertex that we're looking for in this thing's quadratic formula here, function, which is the turning point of the graph. So kind of, if you look at this graph, it kind of goes up and then hits the vertex and goes down. Similarly, if you got one that's going down, then comes back up, that spot where it changes is the vertex. And this particular graph on the right, we have, it crosses the y-axis, that up and down axis, 1 time. And the x-axis here and here, so that would be twice. That is generally how it's going to happen unless you have imaginary solutions. Now, right now, I'm not going to focus on the imaginary things, but we'll talk about those and how they go through as we move forward here. We've got a vertex. We got a vertex, right? That is right there. And that point is 1 in X and 4 in Y. So our vertex is a coordinate point of 1, 4. Notice how I put that in there, that coordinate point, 1, 4 with parentheses around it, indicating a coordinate point. The axis of symmetry, if I look at this and said, well, sketch me an axis of symmetry, you would tell me it would look like this. Because if I flipped the parabola over, that axis of symmetry would look the same. That's why it's an axis of symmetry. Now, when we have a vertical line is the form of x equals a number. In this case, it's x equals 1. X equals 1. So that's kind of interesting. X equals 1, and the vertex x coordinate is 1. Interesting. The y-intercept in this case is 3, or it could be, you could put it as 0, 3 as a coordinate point, or you could just say 3. The x-intercepts, I've got 2 of them. I've got here and here at -1, 0, and 3, 0. Or you could just say -1 and 3. 4 things we're going to need to know in each of these, but we need to figure out how to get to this point. All 3 of these have different ways to get to that point, to find these 4 things. The first one we're going to call standard form, graphing in standard form. We got to find the vertex from this. That, remember, standard form, ax squared plus bx plus c, that's standard form. And to find, we're going to find first the x coordinate of the vertex. To do that, we say that x equals -b divided by 2a. If you say, Mr. Brayman, that looks awful familiar, that looks like a lot like the coordinate, or I'm sorry, a lot like the quadratic formula, you'd be right. It has its origins in there, it has its roots in there. I say origins, roots, it's kind of funny, but that's where it's kind of coming from, right? That vertex point. Once we find the x coordinate of the vertex, we're going to plug that back in to find the y value of the vertex. And then we're going to find some more values to plot around it. We're going to get from that our axis of symmetry. We're going to get that after we can find our y-intercept and our x-intercepts, all that good stuff that we need, okay? So let's say it says graph the function f of x equals 4x squared minus 8x plus 1. This is in standard form. We need to use the vertex formula first to find the x coordinate of the vertex. In this case, a is 4, b is -8, and c is 1. C is not necessarily needed, but it's going to be interesting here shortly in this form. Okay, so if we do this, x equals, again, -b divided by 2a, -8, that's +8, divided by 2 times 4, that simplifies to 8 divided by 8. And from what I can remember, that's 1. The x coordinate of our vertex, if this is our vertex right here, at this point in here, the x coordinate is 1. Great. We can't just know what the x coordinate is. We also need to know what the y coordinate is. So what I have is like a y equals. Well, I do, it's in function notation, but this is the value of the function, or y, when x is 1. We could say as f of 1 equals 4 times 1 squared minus 8 times 1 plus 1. Well, order of operations says we have to do 1 squared first. So this is 4 times 1 minus 8 times 1 plus 1, which is 4 minus 8 plus 1, which I do believe gives us, let's see, -3. 4 minus 8 is -4, plus 1 is -3. Our vertex is -3. 1, -3 right there. And we know because a is positive, it's +4, we know it's going to open up. That point we just found is the bottom of the vertex, right? Our minimum of the parabola. We got to find some points around it. We got to find 2 to the right and 2 to the left. Now, something interesting you may have already been thinking about is, why do I got to find 4 more points? And you'd be right to think that, right? If this is symmetric, if I found 2 to the left, those would match 2 to the right of the vertex, and you'd be exactly right. because our axis of symmetry goes about our vertex, we know our axis of symmetry, our AOS, is x equals 1. So we've got that value. We've got our vertex already. That's good. Well, what's a value that's less than 1 that's easy to work with? I don't know. How about 0? Because that also takes care of our y-intercept. All right, I'm going to kind of put that in here too. Our y-intercept. Interesting, interesting. So if I do that, I plug zeros in here. The value of the function when x is 0 is 4 times 0 squared. Well, 4 times 0 is 0. 0 minus 0, because 8 times 0, negative 8 times 0 is 0, plus 1. Well, that's 1. 0, 1. When x is 0, y is 1. Interesting. Which that also must mean, because this is symmetric, that if I go 1 on the other side, 1 bigger than 1 in x, that's also should be 1. Let's confirm that though, just to be sure. We can do that. 4 times 4, because that's what 2 squared is. So we got 16 minus 8 times 2. So 16 minus 16 is 0, plus 1 is 1. Okay, so we've proved that this is symmetric. That's good. We also found our y-intercept right there. 0, 1, or just 1, however you want to think about it. We got to have a couple more points here, right? Well, I like going by ones in this case. Let's go ahead and do this. -1 and 3. I don't have to find both of them. I just got to find one more. Let's plug this in here. The value of the function when x is -1 is 4 times -1 squared minus 8 times -1 plus 1. -1 squared is +1. 4 times 1 is 4. Minus 8 times -1. This becomes plus 8 plus 1, which gives us 13. So when x is -1, y, or f of x, is 13. And using the symmetry principle, 3 would also be 13. Now that goes off the graph. It's going to be somewhere, I don't know, up in here, and then up in here somewhere. So let's go ahead and just kind of sketch what we got for now. Whoop, that's pretty bad. Sketch up and through here. There we go. Did we do the things we needed to do? Did we find the vertex? We sure did. Right there. Did we find the axis of symmetry? Well, yeah, we sure did, because we have the vertex. We have the axis of symmetry. We actually use the y-intercept. That works out pretty well. I like that one a lot. So we've got the vertex, axis of symmetry, the y-intercept, and a sketch, no matter how bad it is, of the graph. Now, is that a lot? Yeah, the first few times that you've done that, yeah, it seems like a lot. But once you've practiced and you've done these things multiple times, it's going to come a little more natural. In fact, let's go ahead and practice this real quick. Well, first, what you can do is on the second page, it takes you through another one, exactly just about what we did, right? Y equals x squared minus 4x minus 5. You can find the axis of symmetry and the x coordinate of the vertex at the same time, right? X is 2 here. So we've got the vertex because axis of symmetry and x coordinate of the vertex. You found the y coordinate of that, the vertex. You could find the y-intercept, right? You can find a couple points on each side. Use symmetry then to graph down through here. And now you end up with a smooth curve. Again, we don't want V's. We don't want lines. We gotta make sure we have a nice smooth curve. Is it gonna be perfect? No, but just make sure you're doing your best for that, okay? Now let's do an actual extra example here. That's not gonna be on page 3, that's gonna be on page 4. Look at number 1. It says y equals x squared minus 2x minus 3. Right, and again, find the axis of symmetry, the vertex, and the y-intercept, and sketch the graph of these equations. We know that the x coordinate of the vertex is negative b divided by 2a. In this case, b is -2, so -2, that's +2, divided by 2 times 1. So +2 divided by 2 is 1. Hey, that's nice again. The x coordinate of our vertex is 1. We need to find the y coordinate of a vertex. So y equals 1 squared minus 2 times 1 minus 3. Well, this is 1 minus 2 minus 3. 1 minus 2 is -1. -1 minus 3 is -4. 1, -4. We've got that vertex. We know this is going to open up, but this is going to be a minimum because A was +1. Okay. We know our axis of symmetry because it's at x equals 1. Our vertex we just found was 1, -4. We got to find our y-intercept. Well, that's going to work out well. I mean, we got to have two values using our symmetry. If I do two values to the left that are the same distance away, I can find two values to the right that are also the same thing. If I plug 0 in here, 0 squared minus 2 times 0, so 0 minus 0 minus 3, 0 would be -3. And using the property of symmetry, I know 2 would also be -3. 2, -3. If I plug -1 in, y equals, let's try that again. Y equals -1 squared minus 2 times -1 minus 3. Well, let's see here. This is -1 squared is 1 minus 2 times -1, so plus 2 minus 3. Well, that happens to be 0. 1 plus 2 is 3. 3 minus 3 is 0. So if x is -1, y is 0. And if x is 3, y is 0. We actually just found on accident the x-intercepts. I didn't even ask for it, but we found them right there. So -1, 0, 3, 0, and we've got 5 points from which we can sketch our graph. We sketch the graph. We've got the axis of symmetry. We got the vertex. The y-intercept we found because we actually plugged it in, 0, -3, or you could just write -3. And we've got the 4 things that we need, which means what you need to do now is take those same thoughts and try one on your own. When you're done, resume the video, come back, check your answers. All right, if you're saying, Mr. Brayman, that looks like it should have gone off the graph. Your answer, that is correct. I think that's supposed to be -9 at the end. We're going to roll with it because that's what we got in the guided notes for now. Yeah, sometimes things happen. We can still find the answers and get a rough sketch of things, right? We end up with a vertex is 2, 21. Our axis of symmetry is x equals 2, and our y-intercept is 0, 9. We know this opens down because a is negative, and that's what we come to. Yeah, all right, you know what? Sometimes things happen. We'll make that change for later, but right now, these are the values you should have came up with. All righty, let's go ahead and take a look at our second style. Our second style here, oops, sorry, we're on page 3. Second style is vertex form. Now, this should look a little bit familiar to us. We've already seen this. This is a very similar style to what we saw in the beginning of the year when we did transformations. We did translations, and then we also did some stretches and reflections and compressions, all that good stuff. Our vertex is just the values of h and k. It's x minus h, so we take the opposite of this one, just like we did before, right? The inside goes the opposite way we think it is. So if this is 2 times x minus 2 squared, the x coordinate is 2. And then the k value is exactly what we think it's going to be for the vertex. This would be 2, 4. In the same way, -4 times x plus 3 squared minus 5 at the end, it's the opposite for h. So the x coordinate is -3, and the y coordinate is exactly what we think it should be, -5. Again, first find the vertex, and then we can find out the other stuff when we're given it in a form like this. So the example that we're going to work with is 2 times x minus 3 squared minus 4. Our vertex, again, x minus 3, and then it says -4. It's the opposite of what we got in here. So it's 3, comma, exactly what it says, -4. We get that right from there, 3, -4. We know this is going to open up. We know this is going to open up, and our vertex is going to be a minimum because our vertex is 3, -4. Let's go ahead and figure out things. What else do we need to know to graph this? Well, first of all, we got the vertex. We can find our axis of symmetry, our AOS, because it's just x equals the x coordinate. X equals 3. We can do this, 3, -4. Here's our axis of symmetry. And all I got to do now is pick some values to the left and to the right that are smaller and bigger. And what you want to do is pick one smaller and bigger that you can use the axis of symmetry. So here's what I'm going to do. I'm going to go 3 less to give me 0. Mr. Brayman, why'd you do that? Because that also gives us our y-intercept. If I do that, 0, so that's just 3 less than 3. If I go 3 more than 3, 6 is going to be the same as 0. These two are going to have the same y values or f of x values. But I only got to solve for 1 because I'm just using the property of symmetry. The f of 0 is 2 times 0 minus 3 squared minus 4, which is to say this is 2 times negative 3 squared minus 4. Well, 2 times negative 3 squared. Negative 3 squared is positive 9. 2 times 9 is 18. And 18 minus 4 is 14. So 0, 14. Does that go off the graph? Yeah, it sure does, and that's okay. But I've got 2 more values to work with. I've got 0, 14, which is somewhere way up there, and I've got 6, 14. So we'll deal with that later. That's fine. That's fine. We just needed 5 points anyway. I'm going to go just 1 away from this and see what happens. What if I just took 1 away or added 1 to x? What if x was 2? Value the function when x is 2 is 2 times 2 minus 3 squared minus 4. Sorry, get this out of the way here. What we end up with is 2 times negative 1 squared minus 4. Well, negative 1 squared is 1. 2 times 1 is 2, and 2 minus 4 is negative 2. So at 2, we've got negative 2. And using the property of symmetry, at 4, we also have negative 2. So 2, negative 2, and 4, negative 2. What do we say? 0, 14. If we wanted to get more points on the graph, we could. We could just go back to 1 and 5 and check those. I mean, 14 somewhere way up there, right? I'm just going to kind of wing it. Let's just go that way. Hey, that's not bad. I got 5 points. I sketched it. I got my axis of symmetry. I got my vertex. I need my y-intercept, which is right here, my y-intercept. That's when x is 0. That would be 14. Is it perfect? No. But we've got the sketch. We got the things that we needed. We know the shape. We got the general idea of what's going on. Again, this isn't a perfect graph, but it does give us a better idea as well, right? Now, what are you guys going to do? We're going to try one on your own. So if you go back to the next page, I think it's numbers 1 and 2 again on the bottom here. We've got this vertex form. What I'm going to do is I'm going to pause it, let you work through numbers 1 and 2. You're going to come back and check your work, and let's see how you did. All right, welcome back. It's time to check your answers there. Again, here we go. Negative 3 is also 5, by the way. Your answers, I'm sorry, your plots, your coordinate pairs don't have to match mine, but your vertex, your axis, and y-intercept will. And so should the sketch of your graph. If you want to pick some bigger numbers and different numbers, by all means, go ahead. But like I say, make it easy on yourself. Make it easy on yourself and give some ones like that. All right, so we're going to take that next part, or sorry, the next one, the third version, make that into part 2. So right here, go ahead. This is a good time to hit pause. And then we're going to move to the next one. So this ends part 1 of Quad 7. Take care. Have a great day.